Welcome to our CAD programming workshop. If you remember, in the second lesson we learned how to bridge OpenCascade with VTK to visualize our 3D shapes as long as we model them. Today we are going to give a try on our visualization approach, which is more native to OpenCascade, shall we say so. Instead of using VTK as we did in the second lesson, why not use what is called Application Interactive Services? One advantage of this approach is that we avoid additional dependencies such as VTK and instead leverage the full power of OpenCascade library itself. This approach is not my favorite one, but it's not that bad, and if you know how to use it, it might even outperform VTK in certain scenarios. So our plan for today is to start using AIS and then to visualize a simple box shape using this visualization framework, and finally to give it more industrial use case like to read a CAD part from file system and visualize something more realistic. The problem with native OpenCascade visualization is that it's not easy to get started with it, because there is no good kickstart guide available on the internet whatsoever. So let's try to fill that gap and see how one could plug and play this native visualization framework of OpenCascade. Let's start as usual with the main function and see how to add visualization to our console application. So I'm going to create this main function over here and give it a set of arguments like int argc and then char star star argv to give a list of the arguments themselves. And here let's just return 0 for now and check that this whole thing compiles. I'd like to draw your attention that I started from the empty project, which is basically pre-configured for OpenCascade use. If you do not know how to pre-configure your project for OpenCascade use, I would like to direct you to the first lesson on our channel. And to show you what I have, let's go to the properties, and you see that in my C settings in general I have these additional include directories pointing to OpenCascade include directory here, and then in linker in its general setting I have these additional library directories, which is again pointing to libd directory of OpenCascade for debug configuration, and for release configuration it would point to this lib directory. Then in input setting here I have this set of libraries, and I'd like to draw your attention to the fact that I am using now a bit more libraries than before. Like for taking advantage of visualization, I added this tk opengl.lib, tk v3d.lib, and if I remember well, tk service was not available before as well. So what else do we have? In the debugging option here, I have configured my environment by customizing this path variable of Windows. So for release, I make it point also to the bin directory of OpenCascade, so that to have my runtime pre-configured and ready for use. And for debug, it will be this bind directory. Now we are going to add a couple of classes to our console application, and one first class to add is the viewer, which will serve as a facade to all visualization functionality we are going to have. So let's go to the header files here and add a class using Visual Studio Wizard. So we give it a name like a viewer and then click OK. So Visual Studio will automatically put a header file to the header files filter, and then it will also automatically generate an implementation file, which is basically empty. It just includes the header file. Another thing we need to add is something similar to VTK Interactor style, if you remember it. That's basically a controller class that would determine how our viewer reacts to various user events, such as clicking mouse buttons or pressing keyboard keys. For that I'm going to add yet another empty class and name it like ViewerInteractor, because why not? So we have it here right now. And actually implementing those classes and providing them with all the initialization logic for 3D visualization is not a trivial task. Unlike VTK, which provides you a set of classes for visualization, like a render window, renderer, and all these things, in OpenCascade it's a bit more low level, so you have to implement a bunch of things by yourself. And instead of implementing things from scratch, I'd like to direct you to Git repository, which we have now associated with our lessons on this YouTube channel. That's a public repository, and to get there you go to gitlab.com/ssv-lessons. In the root folder here we have some README file and other things, which are kind of housekeeping things for Git. And then we have this lesson 4, Hello OpenCascade. In the future we'll have more directories over here for different lessons. So let's for now go to this lesson 4. And here you can find the whole solution, the whole project we are working on right now. And what we need so far, what we need right now is this viewer implementation with viewer.h and CPP and ViewerInteractor h and CPP. So let's, for example, go here in the viewer.h, and then you can just copy and paste the code from here, like click this button, copy file contents, and then you switch to Visual Studio and insert this code to your corresponding files. So you can pause this video, do this, and then we can continue our exercise. Once you copied the sources, the whole project should compile without any issues, without any problems. So now we have this main function and we have a bunch of things like this viewer facade. And let's start from this viewer facade. Let's see what actually it does. So here we have a constructor which accepts the top left corner of the window it's going to create, and also a couple of dimensions like width and height of the window. Then we have a couple of methods to add our shapes for visualization. The main thing here is this add shape function, which accepts a top-of-the shape, and then it will convert it to the corresponding presentation class, which is AIS shape in OpenCascade. And there is this convenience function, which is a streaming operator, which we are going to use a lot. Then, since we are going to have a window, we also need to associate a message loop with this window. And this is what this method actually does. It runs the message loop. Then we have a couple of things related to Windows API, like we have this window proxy function, which is a static function. So it means that this window proxy procedure is class level procedure. It will be the same thing for different instances of our viewer. But to specialize our procedures, to specialize what we do for each particular viewer, for each particular window, we have this member method, which is this wndproc function, but is not static anymore, and it's an object level function. Then there is this pretty important init method, which provides a bunch of initialization things we are going to take a look on a bit later. And finally we have these member fields, like first thing is a container of shapes we are going to visualize. It's simply an STL vector of top-of-the shape, and then we have a set of visualization facilities coming from OpenCascade visualization framework. The first thing we need to have is a viewer, the main entity or one of the main entities. For a viewer we need to have an associated view, and here we go, and we have a context. Context is the main visualization facade of OpenCascade. Then there is a certain abstraction for our window, which is WNT window. All these handles, they actually mean smart pointers, because OpenCascade comes with its own smart pointer mechanism. And finally we have this handle with smart pointer to our ViewerInteractor, which we just added a couple of minutes before. And finally we have some other things like handle to the module and handle to the window, and we have this boolean flag indicating that it's an exit condition, like whenever user clicks a cross button in the title of a window, we need to exit our message loop, like to break it and to stop execution of our event loop. So let's switch to the implementation details of all this thing. In the constructor of our viewer, what do we have? First, we create a window class. Window class is a pretty important thing, because each window is actually a member of a particular window class. The window class determines the default Windows procedure, which will be shared among all the windows of the certain class. So what do we have here? We create this window class, we initialize this window class structure, we give it like a unique name, we point it to the Windows procedure, which is our proxy. If you remember, it's a static function. And then using the Windows API function, we register this class in the operating system. And what we do else, what's pretty important here, is to create a window and to get a handle out of this create window execution. And here we actually pass the instance of our module, and we register a window of this class which we just declared above, like this OpenGL class here. So finally we show our window, we get its handle, and then we pass its handle to our init method. But before we switch to our init method, let's see what do we have inside this window proxy. So if you go here, we see that it's a sort of conventional Windows API function, which accepts 4 parameters. And basically the main idea here is to react on this WM create event, WM create message. Like whenever we receive this WM create message, we take a pointer to our window and we register this pointer, so that we will be able to call a method of our viewer instead of using just one shared static function over here. So the actual logic is implemented in this WNDproc here. And if you take a look here, you will shortly notice that there is this switch instruction here, which kind of determines how to react on different messages coming from the operating system, like what to do when we have to paint, what to do when there is some resizing or movement event for the window, or how to react on different key press or mouse button clicks. So all these interaction things. And actually there is no real business logic in this Windows procedure, because all the logic is actually delegated to the instance of our ViewerInteractor over here. So basically it's called here Event Manager, and whenever we receive some message from the operating system, what we do, we delegate the real job to this Event Manager. And whenever you want to customize something, if you want to react differently on different user events, like to, I don't know, to have different reactions on holding different keyboard buttons, like to also process control button or whatever other gestures you might want to have in your application, you can consider customization of this ViewerInteractor thingy instead of putting everything to the Windows procedure right here. So this is how things basically work. I'm not going to spend much time here because it's not that related to geometric modeling or visualization. It's some sort of basic things which are pretty standard for Windows operating system. Let us have a quick look at this init method over here. It accepts a Windows handle, which we have out of the Windows creation procedure, and then there is a bunch of stuff related to initialization of different OpenCascade visualization facilities. And I would propose you just to copy and paste this whole thingy, because it's a bit unclear also to me how to initialize all these things. But I'd like to draw your attention to the things which are pretty important, like this lightning, for example. Here we create a couple of light sources. One of them is directional light and another is ambient light. And then we add these two lights to our viewer and enable them using this set light on method. Finally, what do we have? We have a couple of things related to visualization properties, like we access this context drawer, which is default drawer associated with our interactive context, and actually we need this whole thing only to set this boundary draw to true, and this way to tell our viewer that we would like to have not only the shaded display mode of our objects on a scene, but also to draw some edges on them. Then we create a view, and basically here this view we need it to set a window, and you see that we create like a wrapper for our window using the handle which we accept as an input parameter. So basically what will happen inside this WNT window will take care to initialize this graphic context, this OpenGL context which you need whenever you draw something on a screen using OpenGL. So actually this OpenGL rendering context will be created for us by OpenCascade. And also OpenCascade will take out the burden of choosing proper pixel format, so that we will not have to do it by ourselves. So the only thing we have to do is to create this window like this, and then to using this view which we created out of the viewer, we pass this window there to this view, and we are more or less done. After that, then we also adjust some rendering parameters, which is a pretty cool feature actually, because here you can enable anti-aliasing and also to specify the number of samples. If you are looking for very high FPS, then you'd better disable this whole thing actually. Let's also have a quick look at this ViewerInteractor thingy, which is responsible, as you remember, to all the interaction styles between the user and our viewer. So basically here what we are mostly interested in is one method, which is a process key press. If you go there, if you scroll down to this process key press, you will find another switch statement there, which is this one. And what do we see here? For example, whenever a user presses F button on his keyboard, we will feed the scene. Then in order to toggle display modes, like if you want to switch between shaded and wireframe mode, the user can use S and W buttons on his keyboard. And as you might notice, the real job is basically done by this context here, which is a handle to application interactive context. So as I mentioned previously, this application interactive context is a main visualization facade of OpenCascade. We do not use it directly in our own interface because we have this viewer facade instead. But you should be aware that the real job is done by the context, and this is the main entry point to OpenCascade's AIS visualization. So basically, if you want to customize something in your interaction style, you can go to this ViewerInteractor thingy and then provide your custom logic here. For example, in this process key press callback. Well, let's finally come back to our main function and start using our viewer, because we have it initialized and everything compiles. So it's right time to get to some practice finally. So the first thing to do, we include this viewer actually. So we include it as a viewer.h. And we can create an instance of this viewer right in the main function. So I will name it like vout. And now, if you remember, we have to pass like 4 values there. The first couple of values is the coordinates of the left top pixel on our scene, let's say so. So let's pass something like 50 and 50, for example. And then we have to pass also the dimensions of our viewport, the dimensions of our window. So let it be like 500 for both X and Y dimensions. So we have this viewer right now, and since it's a window, actually we need to start a message loop, and I would start it somewhere near this return statement because it's a blocking invocation. So let's do it like vout start message loop, and let's leave it like this for now. Let's try to compile this whole thing and run it to see what will happen actually. So I will also put a breakpoint right in the beginning of my main function, and then press F5. So we see that something is going to happen, and you see the window appeared. And once we are here, if I continue execution of my program, then it will not return because there is this event loop which is spinning and which is listening to all the events. So I have this window, actually it's a real 3D window, although I do not have any object initialized, any object visualized here, but I can try to click my left mouse button and rotate, and you see that there is like a center of rotation which appears, and it disappears whenever I release my mouse button. I can also resize this window, I can do whatever things you would expect from a typical window. But that's not that exciting, so let's try to add something. Let's try to have some shape over here. So for that I'm going to use some OpenCascade finally. So let's include BREP prim API make box to start with, and then I will create a box. I will create, first of all, I will create an instance of this utility class. Let's call it like make box. Then I have to pass the dimensions of my box. Let it be just some random values. And then in order to build the shape, what I have to do, I have to call this build method of the make box. When basically it's a good practice to check that the builder is done correctly, that there is no any problem with that. So I will also put an if statement here to say that, okay, my MK box, is it done or not? Because if it's not done, then there is some error, and I will return just an error code here. And if it's done, then I can access my shape as a const reference to TopODS shape type, which is going to be like a shape, then MK box, then shape method. So here we go, and finally I can dump this shape to my viewer. So this block of code is to make shape, and finally I can visualize it. And I'd like to draw your attention that I'm not creating any presentation classes myself here, because all this will be done by the viewer. So I only have to have this shape, and then once I have it, I can pass it to the viewer, and it will construct this AIS shape presentation object, and it will visualize it without any involvement from my side. So let's visualize it. We can do it as simple as streaming our shape into this vout thingy. So here we go. We can now run it, and you see that there is my box, and I can see it, and I can, if I press S button on my keyboard, I can switch to the shaded mode. And as you see, there is also like this interactive selection working for me, so everything is nice and simple. And you can also notice that there is this anti-aliasing effect, because we kept it. We have these 8 samples of anti-aliasing to have nicely looking scene. So that's pretty easy to do thing, but we can even simplify this piece of code here, because actually we can write it even like this. I can just take this make box and put it here, and then I simply pass all these construction parameters right here, and what will happen actually, the whole construction job will be done in the constructor itself, and then this make box will be automatically converted to top-of-the shape, because there is this conversion operator overridden somewhere here. So we can search for it. It's operator something like, maybe it's not even here. Maybe we can find it in the base class, which is BREP builder API make shape, but somewhere there is this operator. Yeah, so this is a conversion operator, which basically converts our utility class to this top-of-the shape, which is not that obvious for people when we look at code like this for the first time. But let's try to run it as it is now. Yeah, and you see nothing is changed. It still works, and we still have our box shape over here. So let's try to make it more exciting. Let's try to make it less of a toy example, and to see how would you import an existing CAD geometry from file. For that, what we can do, we can go to the project properties and to the debugging options here, and then to pass a command argument. As you see, I already have like a command argument over here, because what I'm going to do, I want Visual Studio to automatically pass this file name to my executable once it's launched. And in that case, what I pass some data file in a BREP format, and it's pretty important to pass a BREP format, because this is a native format of OpenCascade. It's not actually a step file or IGES file. Let's start from a BREP file this time. So what we can do now? First, we need to check that this argument exists. So if argc is greater than 1, then it seems like we have some file name passed in. So let's try to read a BREP file, and we can do this using BREP tools read. So this BREP tools is actually a utility class which is pretty popular in OpenCascade, and it has this static method which is named read. So let's include it first. We need to have this BREP tools.hxx, and then we can read our shape, we can read our file into a shape, and for that we need to specify the first argument. We need to have this shape, then we need to have a file name, and then we also have to pass this BREP builder for some reason. Okay, so let's try to do this. Let's declare shape. Let it be like, I don't know, shape sh, and then we pass it here. And then we pass file name, which is going to be rgv1, because it's a file name, it's a first argument. And then we have to pass this BREP builder by reference. It means that basically we have to create it first. Here we go, we pass it here. We can also check the status code. We can also check what this read function is going to return, like true or false, because if it returns false, it means that our file is either corrupted or doesn't exist. So whatever problem with the file format can also be there. So let's return 1 in that case. And now I want to visualize this shape as well. To do that, I first move this sh variable out of the scope so that it's going to be available for my viewer, and then I simply stream it to my vout. So let's do it like this. Then we compile again, and then we run this whole thing. And you see that my shape is visualized together with this box, because box is also here. And there is my industrial, let's say, part. And you can also notice that it's by default visualized in wireframe mode, and all these gray lines, which you can also see here, they give me a better visual appearance of the part, because these gray lines are also part of my wireframe representation. And if I press S, then I have my part in shaded representation. So it's pretty cool, and you can use it. We can we can use this simple viewer to visualize the results of our modeling, and this way we do not need any third-party libraries such as VTK or whatever. And actually, if you just grab this viewer and ViewerInteractor from the Git repository, which I pointed you to, then it's not that difficult. Actually, we will build upon this exercise, we will build upon the result of our exercise of today in our following lessons. Okay, let's try to sum up what we have learned and also draw some conclusions. So we have this visualization problem, which you have to solve in order to be efficient when you do some modeling. And we consider two approaches. How would you visualize your shapes? Because you might use VTK, which is a scientific visualization library, or you can use also what is named AIS. That was the topic of our today's lesson. This is native OpenCascade visualization framework. Of course, you might want to prefer to build up your own visualization front end using, I don't know, OpenGL, like a pure OpenGL invocations, or even like WebGL if you are sort of web developer, or you can do whatever you want basically, and it's fully possible with OpenCascade to build whatever visualization you might want to have. But we use this VTK and we use this AIS. Let's try to compare with both solutions, because it's not that obvious whether you should prefer one or another. So why and when I would use OpenCascade visualization myself? I would prefer AIS visualization whenever my concern is performance. For example, if I had a huge CAD assembly, then I would definitely stick to this approach, because it has a really nice performance, especially for huge assemblies, and especially if you use it correctly, like if you use a different instancing mechanism, which are also provided in frames of the AIS architecture. This is one thing. When I would use AIS, when I am not going to customize it, like let's say no customization. Basically, it is customizable. You can create your own derived classes inheriting from AIS presentable object or AIS selectable object, whatever, but it's not that easy to do, in my humble opinion, because there is a certain lack of documentation, let's say so. But you can still use OpenCascade codebase as a main volume of documentation. Like, just you have to look through the sources and find the things you need and you want to use. Then I would say that it's really tailored to CAD. It's really tailored to CAD. It means that it does pretty cool job whenever it comes to visualizing CAD geometries, like all these BREP geometries, as topodius shapes, and also assemblies, which are the hierarchies of BREP shapes. And basically, since it's tailored to CAD, you can take advantage of pre-implemented visualization modes such as wireframe and shading, and also what we haven't touched today is hidden line removal mode, for example, all these things. And also it offers pretty darn fast selection mechanism. So what about VTK? Why would we use VTK? What is the added value of VTK if AIS is such a cool framework? Well, actually I would use VTK whenever I have CAD and meshes all in one scene. So when I need to combine both, I will use VTK, because in VTK we've got a first-class support for grids and meshes, and that's pretty important for applications like computer-aided engineering, finite element analysis, all these things dealing with computational problems. So if I'm working in simulation domain, I would definitely use VTK. And for example, if I'm implementing like pre-processing and post-processing software to prepare my CAD geometry to finite element analysis, I would also consider VTK. So we can unite these two things in one item, and then whenever I want to derive a bunch of custom visualization pipelines, VTK is also a good choice, because VTK has a nice and neat architecture. It's very easy to understand and extend, so I would put customization here. And finally, VTK has got a broad community. It has books and forums, and you can get everything you would expect from a decent open source project, so community is a really strong point of VTK. So we have some pros and cons for both visualization framework, and it's up to you to decide what you want to use, what suits your needs better. But for our exercises, for our lessons, I think we could start with AIS, because I think it's a bit less involved. We can easily plug it to our exercises and take advantage of visualization without any third parties and without spending much time on trying to bridge OpenCascade with something which is completely external to OpenCascade. So let's stick to this approach.